Next is question 5, which says organic acids are weak acids, and a 20 centimeter cube sample of the weak monoprotic. Monoprotic means which has one proton, ionizable proton, like CS3COH is a weak monoprotic acid. Concentration with a concentration of 0.150 mole per dm cube was titrated with NaOH, sodium hydroxide, and the pH curve is given. And in this, what we are doing, we are adding base to the acid, and the pH starting from around 3. The first part of this question is determine the concentration in mole per dm cube of NaOH used in the titration. Okay, we want concentration of NaOH, and we have the concentration of the acid is given to us and the volume of the acid is given. Okay, when I have the volume of acid from this graph, I will find out the volume of NaOH. The equivalence point of this graph, this is my equivalence point range. This corresponding volume will be around 18, 19. The corresponding volume of this will be around volume of NaOH I require for this will be around 18. It will be around 18. I think it is 18. Yes, 18 will be the volume of NaOH. You draw a line from the equivalence point range, which corresponds to the point of neutralization, and the point of neutralization will require NaOH 18 centimeter cube. Okay, first I will find out the moles of acid. The moles of acid, the monoprotic acid is equals to C into V. And what is the concentration of acid given to us? The concentration of acid given to us was 0.150 and volume is 20. 0.150 into 20 divided by 1000. That will give us, on calculation, I got the mole 3 into 10 to the power minus 3 mole. And what is this? This is the mole of the acid. Now, since the monoprotic acid, 1 mole of acid will react with 1 mole of base, 1 mole of NaOH. Therefore, the moles of NaOH is equal to same. Moles of NaOH will be equal to the moles of acid, and that is equals to 3 into 10 to the power minus 3, same. Now, volume of NaOH, we find it out, equals to 18 centimeter cube. Therefore, the concentration will be equals to moles 3 into 10 to the power minus 3 upon 18 divided by 1000. On calculating, we got the concentration 0.167 mole per dm cube, which will be the concentration of the NaOH. We will get 2 marks for this question. 1 mark for calculating the moles of acid, and the second mark for calculating the concentration. 1 for this and 1 for this. Next question is, you have to determine the pK of the weak acid using the graph. Now, we know that pH equals to pKa at half neutralization point. Half neutralization point. We'll find out the half neutralization point by the help of graph, and the pH will give us the pKa. We'll go to the graph, and I had plotted a half neutralization. This is neutralization point at 18. Half neutralization point is around 9, and the corresponding pH is around 4.7 or 8. 4.7 or 8. Therefore, my pKa will be equal to pH, and that is equals to 4.7 or 4.8. Next question is, outline why phenolphthalein can be used as an acid-base indicator. Now, answer for this is, since HPH, which is phenolphthalein, has or gives different colors in acidic or basic medium, therefore it can be used as an acid base indicator. In acidic medium, phenolphthalein remains colorless, whereas in basic medium, phenolphthalein turns pink. Thus it can be used as an indicator for acid bases. Next is outline why phenolphthalein is suitable for this titration using section 22 of data booklet. Section 22 of data booklet tells about the pH range of an indicator. and the pH range of phenolphthalein HPH as per the section 22 data booklet is around 8.3 to 10. Now the concept here is for an indicator or for phenolphthalein to be suitable for titration of this, for this titration, the equivalence point range of the titration should lie in this pH range. If I go back to the curve, we can see the equivalence point range is around 8.8. Equivalence point is around 8.8 and the equivalence point range is from 6.2 to 11.2. Since the equivalence point range is from 6.2 to 11.2, which is in line with my phenolphthalein pH range, therefore phenolphthalein can be used as an indicator. So thus what I will write here is, since the equivalence point range or equivalence point of the curve, the titration curve, lies around or lies in line with the pH range of phenolphthalein, hence it can be used as an indicator. Next question is, outline how samples of weak acid and strong acid of same concentration can be distinguished from each other. We can distinguish a weak acid from a strong acid by the help of sodium hydrogen carbonate. Add small amount of NaHCO3, sodium hydrogen carbonate, to both the test tubes of both the solutions. Observation is, sample which gives rapid effervescence of CO2 gas is a strong acid, and sample which gives slow release, which shows slow release of CO2 gas, sample which shows slow release of CO2 will be my weak acid, Okay, so we can use sodium bicarbonate test to identify the weak acid or strong acid. Next, part C of question 5th is the Kw, that is the ionization constant of pure water, is 1 into 10 power minus 14 at 25 degrees Celsius. Question is, the part 1 is, suggest why the Kw of pure water increases as temperature increases. We know that Kw is the ionization constant of water and it is considered as a weak electrolyte. Since answer will be, since the Kw, or we can say ionization, since the ionization of water, which is a weak electrolyte, increases with increase in temperature. Thus, concentration of both H3O plus and OH ions formed by ionization will increase. OH ion concentration and H3O plus ion concentration both will increase, thereby increasing the value of Kw, Since it's a weak electrolyte, it will ionize more with the increase in temperature. More the ionization, higher will the concentration of hydronium ion and hydroxyl ion, thus higher will be the value of Kw. Next is, calculate the pH and pOH of pure water at 60 degree using section 23 of the data booklet. Now section 23 tells that at 60 degrees Celsius, the Kw of water at 60 degree is 9.55 into 10 to the power minus 14. At 60 degree, it is 9.5. Now, H3O plus concentration is always equal to OH ion concentration for any neutral sample of water, and that is I am taking as X. Therefore, my Kw equals to X square, or X equals to under root of Kw. So I will find the value of X for this. X at 60 degree will be equals to under root of 9.55 into 10 to the power minus 14. and the value comes out to be under root, if I find it out, it is 3.09 into 10 to the power minus 7, which is equal to the H2 plus ion concentration. Hence pH will be equals to minus 3.09, pH will be equals to minus log of 3.09 into 10 to the power minus 7, and that comes out to be, pH comes out to be 6.51, and he's asking POH 6.51, and POH will be equals to 14 minus 6.51, that comes out to be 7.04. That will be the answer. Now the next question is 2-methyl propanoic acid and its ester are found in many foods. This is propanoic acid, 2-methyl propanoic acid. Predict the number of signals and the ratio of area under the signals in H1 proto NMR, hydrogen NMR spectrum of 2-methyl propanoic acid. Now the HNMR spectrum, the number of signals depends on the number of different hydrogen environments. Now in this, if I see this CH3 environment is CH and this CH3 environment is CH, therefore both are in same environment, this will produce one line. Next is the CH is in the second, CH is having CH3 on its both sides, therefore the environment of CH will be different than CH3. Hence the second line will be of this CH. The third line will be of this proton, which is of OH. There will be 3 lines. I can say number of signal will be 3. Now ratio of this areas, the ratio of areas will be equal to the number of hydrogen in same environment. So how many hydrogen are there in same environment? 6. That will be 6 is to 1 in other and 1 in the 6 is to 1 is to 1. The number of signal will be 3 and ratio of area is 6 is to 1 is to 1. That will be the answer for this question. Now next he is asking in part 2, predict the splitting pattern of the signals, splitting patterns of the signals. He is asking splitting pattern of signals of hydrogen atoms on the circled carbon. This is my circled carbon. Splitting pattern depends on the neighboring hydrogen. Now since there is one hydrogen in the neighbor, n plus 1, there is a neighboring hydrogen plus 1 will be the number of splitting. Since one hydrogen is present, therefore n plus 1 equals to 2. N plus 1, that comes out to be 2. Thus it will split into a duplet. Okay. Outline why tetramethylsilane TMS is often used as reference standard. There are many reasons for this TMS. Since it has 12 hydrogen in same environment, which is the maximum number of hydrogen atoms in an environment, the first reason for this, it will give a strong signal, and this therefore it could be used as a reference. Along with it, it is inert, soluble in most of the solvents, and can be regenerated and can be removed easily. That's also it is used as a reference standard. Now the next part says the mass spectrum is given to us of 2-methyl propanoic acid. There's a mass spectrum and we can see there are 3 lines and one here also 4. At about 89 there is one MZ peak. The question is the molar mass of 2-methyl propanoic acid is 88.12. Suggests why there is a small peak at M89. When there is a higher than the molar mass, when the peak is higher than molar mass, then it should be, or we can conclude it will be because of the higher isotope of that carbon or the compound containing elements. Now since it is at around 89, therefore it will be for a higher isotope of carbon. My answer should be it could be due to the presence of ionized 2-methyl propanoic acid, 2-methyl propanoic acid with 1 carbon of carbon 13 isotope instead of carbon 12. That's why it should have, or it will have, a slightly higher mz than the actual molar mass. That will be the answer for this question. Next, identify the fragments with mz 73 and 43 for section 28 of the data booklet. So if I draw the structure of 2-methyl, this is 2-methyl propanoic acid. 2-methyl propanoic acid. If the cleavage of this bond takes place from this, that will be CS3. The compound will be CS3, CH and COH. If I calculate the molar mass of 3 carbon, 36 plus 32 plus 31415, 32, then it comes out to be 73. So my answer for this question will be mz peak will be of CS3, CH, COH species, which will be ionized plus. Whereas if this bond breaks from here, then it will be 43, that is CS3, CS3, CH, CS3 plus charge. This will be the second ionized species with mz43. That should be the answer for these two questions. Predict the wave numbers of one absorbance other than 1 due to the CH bond in the IR spectrum of 2-methyl propanoic acid. Now, one will be of the CH bond, another will be of, if I draw C double bond OH, so I will observe that there should be a wave number of the OH group of the carboxylic acid. Thus, for OH group, OH of carboxylic acid, the wave number is from 2500, 2500 to 3000. That will be observed. As per the data booklet, this is the wave number for the OH group of carboxylic acid that should be visible in this IR spectrum. Next is 2-methyl propanoic acid reacts with ethanol in presence of concentrated sulfuric acid as a catalyst. 2-methyl propanoic acid in presence of reacting with ethanol. So when I am reacting an acid with an alcohol, they will form esters. Structural and empirical formula of the product formed. Now what will the product? 2-methyl propanoic acid is CS3, CH, CS3, and it is reacting with ethanol. The ester will be ethyl. This will be the ester formed, and the name of the ester will be ethyl 2-methyl propanoate. Propanoate. This will be your ester. And the condensed formula for this will be C6H12O2. And the empirical formula for this will be C3H6O. If I divide by 2, then I will get C3H6O. That should be the answer for this. I am reacting with ethanol and 2-methyl propanoic acid. The ester will be ethyl 2-methyl propanoate. How I name it? First I will name this. This is my ethyl. And then 1, 2, 3. There is a methyl group on the second carbon and 3 carbon OH propanoate. Okay. Question is question 6, which is NO2, which says NO2 is a brown gas found in photochemical smoke, and NO2 forms from the reaction NO2 in atmosphere. NO2 is formed from this reaction. Now NO is colorless. NO is colorless and it is brown. That is, the solution color changes from colorless to brown. Suggest a method to measure the rate of reaction. Since NO is colorless and NO2 is brown, therefore what is happening in this reaction? The color is changing from colorless to brown. So we can measure the color intensity, change in color intensity per unit time by the help of a spectroscope or a colorimeter. Colorimeter can help us to find out the rate. Therefore, to find the rate, we can measure the change in color intensity per unit time by the help of spectroscope or colorimetry can gives us the rate of this reaction. Next is deduce or determine the order of reaction for each reactant and the rate expression. The 3 experiments are given. concentration of NO is 0.2, 0.2 and 0.4, 0.1, 0.2 and 0.2, 0.28, and the initial rate is 0.28, 0.028, 0.057 and 0.227. If I take experiment, if I look from this data from experiment number 1 and 2, the concentration of NO is constant and this is doubles, and the rate is also doubling, almost doubles. So from, I will write from experiment 1 and 2, concentration of O2 doubles, the rate also doubles, thus order with respect to oxygen is equal to 1. Rate doubles, concentration double, rate doubles, it is, then order is 1. First order with respect to oxygen. Experiment number 2 and 3, the concentration of oxygen is constant and NO is doubled. So when we double the concentration of NO, the rate becomes from 0.057 to 0.227, which is about 4 times. From experiment 2 and 3, the concentration of O2 constant, but concentration of NO doubles, and O2 is constant, but O2 constant, thus rate becomes 4 times. Hence order with respect to NO is 2, second order. It is second order with respect to NO. Therefore, my rate expression will be R equals to K NO square into O2. This will be my rate expression. Next part is determine the value and the units of the rate constant from experiment 3. Here I will take the data of experiment 3. Now experiment 3, the value of rate is 0.227. Using this rate expression, R is 0.227 equals to K into NO concentration. NO concentration is 0.04 and O2 is 0.20. 0.040 square into O2 concentration is 0.020. 0.020 to the power 1. Or I can say K equals to 0.227 upon 0.0227 divided by 0.040 whole square into 0.020 to the power 1. On calculating, I will get Kc equals to 709.3.8. This will be the value of Kc. Now since this is a third order reaction, the unit of Kc will be mole minus 2 dm6 second to the power minus 1. Question is, NO2 can form complexes with metals such as copper and magnesium. Describe the bonding within the complex and the role of NO2 in the acid-base terms. Okay, now in the coordinate complexes, the bond is coordinate bond or the dative bond. The nature of the bond or the type of bond is coordinate or dative, in which one element gives its lone pair for sharing. Now in this case, NO2 is giving its lone pair for sharing. Since NO2 is providing the lone pair for sharing, it acts as a ligand, lone pair donor, and which are lone pair donors? They are Lewis bases. So it is a Lewis base. Okay. Question 7. Winkler method is used to find the concentration of oxygen in water, and we are taking 200 centimeter cube of sample from a river and analyze using this method, and the 3 reactions or 3 steps are given. The part A says identify with the reason the species which is reduced in step 1. Now in step 1, what is happening? The Mn from plus 2 is converting to Mn plus 4, which is oxidation. Oxygen from zero oxidation state is converting to -2. Hence, oxygen is reduced. Oxygen is reduced. Oxygen is the answer. Since oxidation state changes from 0 to -2. Therefore, it is a reduction. 4.8 into 10 power minus 3 mole of I minus was formed in step 3. Determine the number of moles of oxygen in the given sample. If I see this equation, 2 mole of thiosulfate reacts with 1 mole of iodine and forms 2 moles of I minus. So I can see 2 moles of I minus forms 2 moles of S2O3 2 minus, and 1 mole of iodine. 2 moles of I minus gives 1 mole of iodine. 1 mole of iodine reacts with 1 mole of MnO2, and 2 mole of MnO2 reacts with 1 mole of oxygen. Therefore, if I go reverse, I find out the ratio between the I minus is to O2 will be 1:4. Hence, the moles of O2 will be equal to, oxygen will be equals to 4.8 into 10 to the power minus 3 divided by 4. That comes out to be 1.2 into 10 power minus 3 mole. That will be the answer for this part. Now calculate the concentration of oxygen in gram per dm cube in the water sample. If you did not obtain the answer, is use 2 into 10 power minus 3. But we got the answer. It is 1.2 into 10 power minus 3. Now we have to find out the concentration of oxygen in gram per dm cube. This is the concentration this is the moles of oxygen. 1.2 into 10 power minus 3 mole. Concentration will be moles upon volume, and the volume is 200 centimeter cube. Mole is 1.2 into 10 power minus 3. 1.2 into 10 power minus 3 upon 200 divided by 1000. That gives you concentration is, and I have to find out the concentration in mole per dm cube, but I have to find out in gram per dm cube. Therefore, I multiply it with the molar mass of oxygen, 32. When I multiply it with 32, I will get 1.92 into 10 to the power minus 1 gram per dm cube. By multiplying the concentration mole per dm cube with molar mass, I will get the concentration in gram per dm cube. This will be the answer for this question. Now next question, which is the last question of this paper, is question 8. There are 8 questions in this paper, and this question says the Voltaic cell is made using a nickel electrode, and there's one nickel electrode and a silver electrode, Ag. Now in this cell, since the electrode potential of nickel as per data booklet table 24, we see the electrode potential of nickel is minus 0.26 and silver is plus 0.28. Nickel will act as my anode. Therefore, the anode will be nickel. Nickel will be my anode. And the electrolyte here will be nickel nitrate, NiNO3 whole twice aqueous solution will be my nickel nitrate electrolyte. Whereas the cathode will be silver. Silver will be my cathode, and silver nitrate AgNO3 aqueous will be my electrolyte of this cathodic container. The electron flow from nickel, because nickel is at higher potential if they lose electron, whereas the current will flow from, the direction of electron flow will be from nickel to silver. This will be the flow of electron. Nickel to silver will be the flow of electron. Electron will flow from nickel to silver, electrons, and the current will flow from, the direction of current will be opposite to this. Current will be from silver to nickel. This is all about the part A, and the part B says outline why a salt bridge must be included to connect the two half cells. Now salt bridge is very important part of this, a very important component of a Voltaic cell. This salt bridge helps or has 3 functions. Salt bridge helps in number 1, it neutralizes the charges collected at the 2 electrodes. Neutralizes the charges collected at the two electrode, charges at the collected at the neutralizer charges collected at the two electrodes. The two electrodes by transferring charges from one electrode to another electrode without mixing them from one solution to other. Number one. Number two, it maintains the continuous flow of current. The continuous flow of current by completing the circuit. Completing the circuit. That will be the answer for this question, and this completes the paper of November 2024. Thank you for watching. I hope this will help you for understanding the concepts and the answers of this paper November 2024. Thank you very much.